All right, how about if I say more than VHF?
The idea for this project grew out of an ADAC-Arctic ions workshop, which was centered on oil spills in the Arctic. And at that workshop, we identified that oil spill modeling in the Arctic needed to be addressed, and we needed to understand more about it.
The purpose of having better models is so you know where to put personnel, where to put your resources. And by being better prepared ahead of time, it makes it so if there is an incident, you have infrastructure there, you have people there, you have resources there. And there's already an element of that in a lot of the rest of the parts of the world, but the Arctic has so many unique challenges that aren't found in somewhere like the Gulf of Mexico.
Our project has a really good relationship with our core team. We meet very often, so we're able to make decisions on the fly and adjustments as we find need. And what we found in our original core team meeting is that there's a need for the responders to know what is the uncertainty that the models are providing, so that they can better respond and know where to place their personnel and their equipment in the best locations that they can.
You need to be able to predict where that oil is going to go, because you need to either protect resources where that oil might be going to go, or you may want to warn people that the oil is going to go there. The other important difference in the Arctic is that there is very limited resources. So if, for example, an oil spill occurred near Nome, the logistics in Nome are not good. There are not a lot of vessels there. There is not a lot of oil spill response equipment there. There are not a lot of responders, so they all have to come in. The city of Nome is not set up to have hundreds of people come in for a response. So all of those things mean that we have to quickly understand what is the threat, where is the threat the worst, and how do we muster the limited number of resources that we have to quickly get to those spots that are the most critical. So you have to start immediately thinking, where exactly is that spill going to go? Not, oh, it could go any place in a 200 or 300 mile stretch. Where's it going to go so we can get people there? And we've dealt with all sorts of questions related to oil spills, from things like dispersant use, food security and food safety, things such as submerged oil. And a lot of what we deal with is questions regarding modeling, because modeling is the key way that during a spill, especially at the initial moments of the spill, when information starts coming in, NOAA starts cranking up models to predict, with the information that they have, where that oil is going to go, what could be potentially at risk from that oil, and in what ways we respond. Do we respond by putting out skimmers? Well, maybe the waves are too high and you can't do that. So that model helps you decide which tools can be used for response. One of the problems when you have groups all over the world developing models is that you don't always know exactly what this model is doing versus that model. And so one of the big things about our project is to bring together experts from all over the country and all over the world to talk about the best path forward. We had a workshop in December, and we had the world's leading oil spill modelers come together to talk about what their different models do and what they don't do, and understanding if you're using that equation to figure out that process and I'm using this one, we might get very different answers. Now we begin to understand why we might get different answers, and we can begin to ask the question, well, in this particular spill scenario, might this approach be better than that approach? So there are two scenarios that come to mind. One is once you have shipping or even fishing vessels, you have fuel prone to being spilled when there's an accident. And the second scenario is certain places in the Arctic, there are oil wells in the ocean, and those could also have a blowout.
The whole purpose of this project is to improve the tools that the Coast Guard has to respond to oil spills in the Arctic environment. So part of the deliverables of this project is going to be as a knowledge product, which will really synthesize all the findings we have to serve as some guidance for where these response models can go next. One of the Coast Guard roles that we're actually really interested in with this project is the role of the Federal On-Scene Coordinator. Because, you guys as Coast Guard are some of the first people out there really hands-on responding to this spill. And NOAA, as the government agency responsible for giving scientific support to the Coast Guard, is another one of our key partners on this project. And what we really want to help do is bridge that gap between the people working on oil spill models and the people using oil spill models.
And we asked them, what do you need from models during oil spills? And on what time scale do you need it? Our normal models that ice modelers run sometimes, those models run for 24 hours. They're very fine scale. So we asked these users, what are the most important factors for you? And two things stood out that really didn't relate so much to the equations and the models themselves, but were very important to them as users. One was visualization. How can I quickly see what the model is telling me? And how can I use that to explain to others what's going on? And secondly, how do I explain the uncertainty that's associated with what the model predicts? So when you say to a scientist uncertainty, they think about numbers. The uncertainty is plus or minus this. But for a responder, what they're really thinking about is, what's the risk it might be wrong? The second phase was to pull together all of the experts on ice modeling and oil spill modeling and bring them together to Anchorage to have this workshop where we dug deep into what the state of science of oil spill modeling was and of the ice modeling that informs the oil spill. And how did that line up with what the clients told us that they needed out of the models? And after that workshop, we came out of it with 4 working groups. And those working groups are attacking different gaps and questions that need to be resolved in the model. One is looking at oil-ice interactions on the very small scale, the meter scale. The second group is looking at oil-ice interactions on the kilometer scale. The third group is thinking about how do we use existing and new technologies to get information into the models. And the fourth one is looking at what the clients need for visualization and how do we express uncertainty. And then in October, we'll bring everybody back together and then we'll write up a report that will basically be a knowledge product that the Coast Guard and NOAA can use to refine the models with these recommendations and potentially to understand what the gaps are and where they need further research.